If you're interested in concrete wall forming, you might be interested in the Gates wall forming system. The way this works is use 3/4 inch plywood and 2x4 whalers. Drill holes in the plywood, 14 holes per sheet of plywood. The first holes are close to the bottom, and the last holes are close to the top, and the spacing in between is even. And the way these are set up, the hole on the side is the same as the hole on that side. This is 2 feet spacing, that's 1 foot. So this ends up being 2 feet between the pieces of plywood. And the plywood can be flipped over. It's got a cute little animation on their instructions that says no top, no bottom, no front, no back, because it's symmetrical side to side and top and bottom. So the Gates cam locks, these are called cam locks, are pretty nice. They're pretty easy to use. They have a cam. They hold up the 2x4 like that. They press against the plywood there. They hold the snap tie there. So that's the cam lock. There's a snap tie coming through the hole. It's a 13/16 hole. These are D-cone snap ties. They have different, let's see if I can get that in there. So if you oil these things, they move a little smoother. If they're not oiled, sometimes they could be stiff. But you can do it with one hand. Sometimes. Put this thing in there. And they'll cinch up. If the 2x4s are wet, if they're still green, it'll cinch up pretty tight. If the 2x4s are dry, they won't be super tight. You can do them by hand. Sometimes you need to use a hammer if they're very tight. This is the D-cone snap tie, and that fits right in between those pieces of plywood. This plastic right here will plug up the hole. This loop will hook on to the bottom or hook onto that cam lock. The way those cam locks work is the ones on the bottom are upside down. These ones hold up the 2x4. And you screw in these bottom 2x4s to the concrete so the forms don't lift up when you move them. When you splice a 2x4, you could just put a board there. I'm using these Simpson. These are Simpson screws. They're for Simpson metal connectors. The reason I'm using these is so that they don't clog up with concrete. There's some, they call them duplex screws, which would work. They're made for this. And the duplex screws might be better, but I haven't tried them. I'm using these because they don't have a hole that can get filled with concrete, and they're available locally, so they work for me. So the plywood needs to be drilled with 14, 13, 16-inch holes, and it gets put up there, 2 sides. So this is what a piece of plywood looks like. It's drilled. I used these before. The plywood changes color from that to that after the concrete touches it. To plug up the holes, Gates sells this little plug that costs 14 cents locally. So that will go in there. Plugs up the hole. If you want to reuse the plywood, you don't want a hole. If if you don't want a hole where the plywood is, or where the, if you want to plug up the hole that you previously used. This is the finished concrete wall. So this is what it looks like after the snap ties are broken off. They can be patched. Before they're broken off, they look like that. They stick out there. I'm using them to hold up my tarp right now. So the window can be framed out inside. Over here I have a couple windows framed out inside. So right here, there's no snap tie because there's a window frame in there and it got in the way of the snap ties. The snap ties can go right through the middle of a window, but this one happens to be in the way of where it's framed out, so I couldn't put the ties there. But there'll be less concrete pressure there because of the window, so I don't think it needs the ties. So those are the Whalers. I'm going to put another 1.5 feet up here because my walls are a little bit higher. And so the way that works is I use these sheets that have 4 holes. They're about 1.5 feet tall. And there'll be one more 2x4 right on top of that one, and then one higher up. So there'll be 2 more 2x4s on there. And then that 2x4 that's directly on top of that one can get screwed to that one, so it'll be a rigid system. And one more part of the system is these. These are the Strongback brackets. I think they call them brackets. The way these work is these Whalers hold the wall straight in this direction. The Strongbacks, there's a strong. You can imagine that board up against those will hold it straight vertically. And I'll try to put this in with one hand so you can see. I'll try. So they got these, this is the Strongback. I think they call it a bracket. Let's see. So that's gonna clip on there. That clipped on there. Then I'm gonna come over to this side. I'm trying to do this with one hand. There it goes. That clipped on there. So that's clipped on, and then it has a little cam sort of mechanism down here. So what you do, see how that works? You push down on here. Now that's nice and tight. So that 2x4 is now tightened up against the wall. I would normally put, they also sell a scaffolding attachment that goes up here that you could stand on. You could put planks on, you could stand on it. And these Strongbacks will hold up that scaffolding attachment. So if you use that, there's some instructions here. You have to put a certain number of Strongbacks. Let's see if we could, that's the scaffolding attachment. And right here, I think that's attached to the scaffolding. But there, and there are those those brackets I just put on. And they hold the strong backboard. And these are the Whaler 2x4s. And they'll hold up the scaffolding. The strong backs can also be used without the scaffolding just to keep the wall straight. So I'll probably put I'll put one clamp here, probably here, and probably up there. And that'll be enough to hold it straight. And I'll put one of those probably every 6 feet. I'm not using their scaffolding. I used it before, it worked good. I just don't want to rent that many pieces. And I happen to have a whole bunch of 4x4s that I'm going to use for shoring. And it's easy enough to just put the 4x4s up like that and put in a couple of screws. So I'm just going to make my own scaffolding. It doesn't take me long to put in a few screws like that since I already have the 4x4s. And the 4x4s I'm going to use together with this one's these are Ellis jacks, and they'll hold up. They'll connect 2 4x4s together that can be adjusted to hold up shoring up here for the suspended slab. That's why I have a bunch of 4x4s. So that's why I'm not using the Gates scaffolding. So these D-cone snap ties are shown here. They're 8 inches from here to here. So they measure your wall just by attaching them on there and cinching them tight. Your wall ends up really close to 8 inches. And those D-cones seal up the holes. And then the D-cones leave these indentations, which can be patched later. These indentations can be patched using divots, I guess. Can be patched using a mix of concrete, of cement and fine sand, or a special patching compound. I haven't done it yet. I'm not sure how much it'll smear. I'm not sure how evenly it'll match, but that's the idea. So this project here has one wall formed, more walls getting formed, and then a rebar placed already. So should you place the rebar prior to putting up the forms, or should you put up one side of the forms, lay your rebar, and then put up the other side of the form? I don't know the answer to that question. Obviously, I placed my rebar first because I started placing it and I just finished placing it all at once. But would it have been easier? Another possibility could have been to put one side of plywood, brace the plywood. And here's what you use to brace the plywood: a stake and a form aligner. These form aligners have these threads that won't get clogged with concrete or cement. They turn pretty easy. They attach to a 2x4, so you can make them whatever length you want. They have a big hole in the bottom, so you could drive a stake in the ground, a steel round stake, and then they're kind of angled at the bottom. And they have holes on there, so you can screw them onto 2x4s if you want to screw them onto a 2x4 up there. So these form aligners could hold this piece of plywood plumb. The plywood could have these brackets on it, or these Gates cam locks. The Gates cam locks would hold the snap tie even without this 2x4. They'll hold it all by itself. The snap tie would stick out of here without, and this side would not be on there. And this would just be sticking out, and then the rebar could be placed here, and then the other side of the form could be placed later. that would be beneficial in a way compared to how I did it, because the way I did it, this rebar was already here, and sometimes when I put the forms on afterwards, sometimes these snap ties would hit where the rebar was. And then when they hit where the rebar was, I would have to cut the tied rebar, the ties, and move the rebar. And that just kind of slowed me down and made me tie the rebar twice at times. And if I placed the rebar after the ties were in there, that would never happen. And also the rebar, I would have something to work off of. If this was rigid, held in place by the form aligner brace, the brace with the form aligner adjuster, this could be plumb, and then this can reference off of this to be placed correctly. Might make it easier to place, and you can get the right distance easier, and these wouldn't interfere. And maybe the rebar could rest on here, maybe not. I'm not sure. It might not be strong enough, but the rebar can support itself on the ground, and it could probably be tied on these just to get your distance from the form. So that's the Gates cam lock system. I rented these at Whitecap. I think they cost me, how much did they cost me? I think some cents per month, maybe 17 cents, maybe 30 cents per month each. So let's just say, I don't know if it's 17 cents or 30 cents, but I remember those numbers. Let's say 30 cents a month. Let's say there's 14 on there. Let's say it's $5 approximately for each side of the board. 5, 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then the rest, maybe $200 to rent those for a month. These Gates D-cone ties, 8 inches, I believe cost me $2 each. So 1, 2, 3, 4, 5, 6, 7, 8. There's about 20 sets of plywood there. 20 times 14 is about 300 approximately. So maybe $600 for the D-cone snap ties. And there's the box. Has a handy table that shows you, this is the rate of placement per hour for your concrete. So if you place at 5 feet per hour and your temperature is 60 degrees, the pressure of the concrete pushing out on the bottom of your form down here, if you had 5 feet of concrete in there, the pressure on the bottom of the form would be 900 pounds per square foot. So the way you pour these, pour the concrete in the top, it comes down, when it gets up to 5 feet, you have 900 pounds per square foot pushing out on the bottom of your form. So you wait an hour, this concrete solidifies mostly, and then you pour the rest. And then you have 900 pounds per square foot pushing out here, 5 feet down from the top, if you're making a 10-foot wall. The pressure on the bottom of your form will vary depending on how quickly you place your concrete per hour and the temperature. If it's cold, you end up with higher pressures than if it's hot. If it's 90 degrees and you place at 5 feet per hour, your pressures will be 650 pounds. If it's 40 degrees and you place at 5 feet per hour, your pressure will be 1,275 pounds. So in cold weather, you have to be careful not to place too fast because your pressures can be pretty high. If the weather's hotter, like now, it's pretty hot here. It's about 90 degrees. Before I placed, the temperature was closer to 60 or 70. I placed 5 feet and probably reached pressures about 900 pounds. Now it's 90 degrees. It looks like I can place 10 feet per hour and still get 900 pounds. So instead of doing this in 2 lifts, I could probably do it in 1. You can see the difference between a lift here. This was a lift that stopped here. It's about 5 feet. And then I waited and poured another lift. So you can see there's a seam. There's kind of a visible seam there. It blends together pretty well there, but in other parts it does not blend together so well. And this is my first time pouring a wall like this, so I learned a little bit of a lesson with the vibrator. I knew already that the vibrator needed to go down into the previous lift to blend that seam, but practically during the pour that didn't happen. So I ended up with those, and kind of severe over here. They can be patched and they don't really bother me, but I did learn, I got experience in that regard. I already knew, I read about it, I just didn't make it actually happen during the pour. So the load ratings for the ties, these are 4-gauge ties. So they have a load of 4,500 pounds, ultimate load. That means this tie can support 4,500 pounds of pressure or of force, pulling those sides of the form apart. There's a safety factor, so you don't want to bring them all the way to their ultimate load. If you want to use a safety factor of 2, basically you get half the rating of the tie. That means they won't break when you use them because you're being safe. So they can support 2,200 pounds per tie with the safety factor of 2. So at 2,200 pounds, these are per foot. This 2,200 is per tie. So then you have to look over here. How many feet is each tie supporting? So there's a tie behind here. There's 2 feet between here. So this tie is supporting to here. This tie is supporting halfway to there. So that's 1 foot. That's 1 foot. And then between here and here is a little bit more than a foot. Let's call it, I don't remember how much that is. I think it's slightly over a foot. Let's just call it 6 inches. Let's call it half a foot. So half a foot and half a foot. So it's 1, that's 2, and this is half, and that's a half. So that's 1. 2 times 1 is 2 feet. This is supporting 2 square feet. So if we go over here and look at our chart, and we think, okay, we're pouring, let's just say 60 degrees. We're pouring 5 vertical feet at a time, so you have 900 pounds per square foot. Well, we have 2 square feet per tie, so that comes out to 1,800 pounds per tie. So if you're pouring 5 feet at a time at 60 degrees, and you have 900 pounds of pressure per square foot of wall, and each tie is supporting 2 square feet of wall, then that means each tie is supporting 1,800 pounds of force. Well, if you look over here, your factor of safety, or you're at a 2 factor of safety, 1,800 pounds is below 2,200 pounds. so it's not going to break. All good. Yep, so that's kind of the basic calculation. This pattern is a standard pattern, and this is on the box. And I poured during my first pour. The pumpers got a little carried away and they went higher than I wanted them to. And so this first part in the beginning, before I told them to go a little bit lower, was about 6 feet. And they poured that right here within minutes. So that was the full pressure of the concrete at 6 feet. And so the full pressure of the concrete, let's just look at the lowest temperature at 6 feet, would be somewhere around 1,500 pounds. And everything held okay. So that was a little bit, I think it's 150 pounds per foot is the weight of the concrete, I believe. So 150 times 6 would be about 900 pounds. Times 2 square feet would be 1,800. I'm not sure that math is right, but I am sure that at 6 feet, poured within a few minutes, that bottom held okay. But it did start to spread the plywood a little bit because the end of the wall, the tie was there. I'll show you what it looks like over here. The bottom of the wall looked like this. There was a tie here, no tie until the end of the wall. The end of the wall was supported by a 2x4 with some screws. And this part of the form is starting to widen right here, this part, because it was a little bit away from the tie and there wasn't another tie over here. And it was poured 6 feet within a few minutes. And so it widened a little bit, like maybe, I don't know, 1/8 of an inch or 1/4 of an inch. Now, this time I put screws in here, so it probably won't widen. And it's not really visible in the wall. And that was just the first part. So I kind of learned a little bit there. This project's going to have a concrete floor, more walls, and a concrete roof.